We're going to take a look at activity 1.1.5, gears, pulley drives, and sprockets practice problems. So very similar to our simple machines practice problems. We're going to be answering some questions about gears though, pulley drives, and sprockets, and we're going to want to make sure to provide proper illustration, annotation, labeling of forces, distances, direction, unknown values. Illustrations should be just basic, view assembly sketches rather than a realistic pictorial. And we want to make sure to document all our steps. And remember, counted teeth have infinite digits. We're going to assume all other measurements contain 3 significant digits. And we're going to assume ideal conditions and no friction loss. So, as we go down in this first video, we're going to take a look at the gears problem, numbers 1 through 4. So here we have a simple gear train composed of 3 gears. Gear A is the driver and has 8 teeth. Gear B has 24 teeth, and Gear C has 16 teeth. So again, as far as to draw these out, I would go through, I'm going to set up three gears here, and we'll go ahead and label this as A, B, and C, and just above it, we'll put the number of teeth above, and that's really all we need for this kind of diagram. So for number 2, they're saying if the output is at C, what is the gear ratio? So we're assuming gear A, and they even said up here, the gear A is the driver. So that's going to be, that means this is the input. So they want us to find the gear ratio, number of teeth out over the number of teeth for the input. So my gear ratio over 1 is equal to, so as I substitute in, I've got 16 on my output gear, 8 on my input, and as I reduce this down, I get a 2 over 1. Here, my gear ratio is a 2 to 1. So again, comparing those 2 gears, that input and that output gear as we go along. All right, flipping on to page 2. That was numbers 1 and 2. As we look at number 3, it says if gear A rotates at 60 RPM, how fast is gear C rotating? So this is going to be a proportion that we're going to set up. So when we look at our formula, I'm going to use the same information from the last one. I do know the number of teeth out over the number of teeth in. Now watching your formula sheet, when they talk about rotation, they're talking about angular speed. And the thing you got to watch, this is the only variable in that list, if you notice on the formula sheet, that has in over out. So you got to watch where you're plugging your numbers. So in this case, I'm going to use the gear ratio, in over out, we reduced that down to a 2 to 1 ratio, is equal to, gear A is the input, so that's going to be 60 RPMs. And we're looking for the output angular velocity. So as we go through and look, so cross multiply divide, your output is going to be 30 RPM. They said we're going to have 3 significant figures. So I'll go ahead and put 30.0 there, and that's 30 revolutions per minute. So again, cross multiplying, dividing, being able to find that answer. Which, if you check, gear C is twice as large as gear A, and a larger gear means it turns slower. So gear A is turning at 60 RPM, gear C is turning at 30. It makes sense. If we were to calculate this and mess this up, and our RPM was higher than gear A, that would kind of tell us we've got something wrong mathematically. All right, and then number 4, same kind of scenario. If the output of torque at gear C is 150 foot-pounds, then what is the input torque at gear A? Same kind of scenario, we can set up a proportion to kind of check this out. Now this one here, torque out over torque in on the right side. Again, I can go through, plug in 2 over 1 for my number of teeth. That's the reduced gear ratio. And then my output torque, they're given to me. They already told us what is here at C. So 150 foot-pounds over what is the torque for the input. So again, cross multiply, divide. I'm going to find that that input torque should be 75.0, so 3 significant figures, foot-pounds of torque. So again, gear C is bigger, so it's going to generate more torque, but less speed, which we found up here in number 3. And here we find gear A, since it's smaller, it's not generating as much torque as gear C. So again, this makes sense. So in our 2 to 1 ratio, it's going through and kind of communicating